today I'm going to go over the review for Test 5 Graphing Quadratics. I'm going to go through and just do one of each kind first, and then I'll go back and do the rest, but that way maybe you don't have to watch all the video. So axis of symmetry is x equals negative b over 2a. You have to memorize that. That is the only formula you have to memorize. Standard form, ax squared plus bx plus c, and vertex form is y equals a x minus h squared plus k. All three of these on the first page are standard form. So I will work one of these, and then in subsequent videos I'll go ahead and finish them up. I'm just going to do this first one. So I have 1/2 x squared plus 4x plus 7.5. So to find the axis of symmetry, or the x-coordinate of the vertex, I'm going to do negative b over 2a. So negative 4 divided by 2 times 1/2. So negative 4 divided by 1. I get negative 4. That is my axis of symmetry and the x-coordinate of my vertex. Once I have that, I go ahead and plug that back in to get the y of my vertex. So negative 4 squared is 16, and then minus 16 plus 7.5. I have 1/2 times 16 gives me 8. So 8 minus 16 gives me negative 8, plus 7.5 gives me a negative 0.5. That is the y-coordinate of my vertex. So I have the point negative 4, negative 0.5. My y-intercept is always the c value, so 7.5. I know that this opens up because a is positive, so I have a minimum. My domain is always negative infinity to infinity. I found the lowest point because this is my minimum, it is my vertex, so then I know it goes from negative 0.5 up to infinity. Now I use my counting pattern. Normally, this is my counting pattern, but I need to multiply those all by 1/2. So if I multiply them by 1/2, I get 0.5, 2, 4.5, and 8. So if I go out 1, I'm going up 1/2. If I go out 2, I'm going up 2. And there is my parabola. Solutions are another way of saying x-intercept. So where does it cross the x-axis? Negative 3, 0, and negative 5, 0. Alright, so that is standard form. If we flip onto the back, all of these are vertex form. So I will do one of them and then go back later on and finish them up. So I'm just going to do, the second one this time so that we have one that opens down. So I have negative 1/2 x minus 6 squared plus 4. Remember, my vertex is h and k, and insiders lie. So this is going to give me a vertex of 6, 4. My axis of symmetry corresponds to the x-coordinate of my vertex. It is opening down, which means I have a maximum. My domain is always negative infinity to infinity. On these, to find your y-intercept, you are actually going to have to plug in 0 for x. So 0 minus 6 is negative 6. When I square that, I get 36. So negative 1/2 times 36 gives me a negative 18. And if I add 4, I get a negative 14. So if you see, it's the very last point that is on your y-axis. Alright, same thing right here. I have the counting pattern. This time I'm going to adjust them all by a negative 1/2. So this gives me negative 0.5, negative 2, negative 4.5, and negative 8. So I'm going to plot my vertex, 6, 4. If I go out 1, I'm going down 1/2. If I go out 2, I'm going down 2. I can connect my y-intercepts, and there is my parabola. Range, since this goes down, it's negative infinity all the way to 4. Alright, when you convert a vertex form into standard form, we are going to multiply. So if I say x plus 2 squared, it really means I have 2 of them. So I'm going to go ahead and say x plus 2 times x plus 2. Once I have this separated out, I need to FOIL or double distribute. So I'm going to do x times x times 2, 2 times x, and 2 times 2. I'm going to combine any like terms that I have inside the parentheses. So I have 2x and 2x gives me 4x. Right. This negative 3 on the outside needs to be distributed to everything inside the parentheses. And the last thing you need to do is combine these two constants at the end. So I have a negative 12 and a minus 4 gives me minus 16. So that is standard form. Okay, on these problems you are writing them into vertex form, so you do not need the calculator. You locate the vertex, so that is at the point 4, 1. Remember, I'm filling in this equation. This becomes my h and my k, so the only additional thing I need is a. I use my counting pattern. If I go out 1, where does my graph hit? And I figure out how much I actually changed. Well, that's 2, so in this case, a is 2. Remember, insiders lie, so I write it as a negative 4. Okay. I'll do one more of these. This one opens down. I have a vertex at 0, 3. Again, I'm going to go out 1, and where does it hit? And I see what that changes. Since I went down, it is a negative 1. So this time, my a is a negative. Okay. All right. These problems, where you're going to write it into standard form, you're actually going to use your calculator. So the first thing we need to do is go ahead and identify the actual ordered pairs on my graph. So they are points that have been chosen for me, and I just need to figure out the coordinates. So I have the point 5, 2, 4, negative 1, and 3, negative 6. Once I have located those, I'm going to go to Stat, Edit. My x's go in L1, and my y's go in L2. Stat, Calc, Quadrag, and then I'm going to go down to Calculate. And that is going to give me the standard form of my quadratic, and here it's telling me what A is, B, and what C is. So as I fill them in, I get my equation. Okay. You do the same thing on 14, 15, and 16. Down here at 17, remember that when we say roots, we're really saying solutions, x-intercepts, or zeros. Those all mean the same thing. It's basically asking me, where does my graph cross the x-axis? So I locate those points, and I identify the ordered pairs. Ones like this, where it just comes down and touches the x-axis, it means you only have one root. So I only have the root negative 4, 0. Same thing on 20, 21, and 22. Now 23 and 24 are your word problems. So here is the equation. We're looking at a basketball that's being thrown up, and here is the equation that models its path. If we want to know the maximum height, we're really asking for the vertex, because we know max and mins occur at the vertex, so if I can find the vertex, I have found the max of the min. This is in standard form, so I'm going to use my negative b over 2a. So negative 45 divided by 2 times negative 16. So I get negative 45 divided by negative 32. So I get 1.406. That tells me when it happens, but it doesn't tell me what the actual max is. To find the actual max, I need to plug that back in. Right, and again, I can just plug that directly into my calculator as long as I have my parentheses in the correct spot. And I get 37.641 feet. So that is the maximum height. If no one touches the ball and it doesn't hit anything, how long will it be in the air? We're basically asking, when will it come down here and hit the ground? Well, we know that those are zeros of my functions, so I need to find the zeros of this, or the x-intercepts. That is what we did last unit. I can use the quadratic formula, or I can actually graph this equation in my calculator. And I can see, even though I can't see the top, I can see right here where it intersects. So if I go to second calc, we have an actual choice called a 0. If I pick that, left bound just means I want to be on the left-hand side of where it's intersecting. And here's my blinking cursor. Well, I'm on the left-hand side, so I can hit enter. Now it's asking me for a right bound, so I just need to arrow until I can get my blinking cursor on the right-hand side, hit enter. And the last thing it says is guess, and there is my answer, so 2.94. So it will be in the air for 2.94 seconds. Alright, so I graphed it, and then I hit second trace, and then I chose 0. Okay. Same thing right here. We are looking at maximum height. You're throwing a beanbag, so I'm looking at maximum height. I want vertex. Down here, I want to know how far it traveled this way. So again, I'm looking for my 0. Alright, 26 through 30, you're trying to find what value of C will make this a perfect square trinomial. In order to do that, remember, I take B and I cut it in half. So 20 divided by 2 gives me 10. And then I square it. So C would be 100, which means I really have the trinomial like that, which gives me the perfect squared x plus 10. If it is subtraction, it still works the same way. I do negative 10 divided by 2 gives me a negative 5, but negative 5 squared still gives me a positive. The only thing that is going to change is when I come down here to write it in its factored form, I keep that negative. Alright, these are completing the square, so it's changing standard form into vertex form by completing the square. So I'm going to choose this one right here. First thing I'm going to do is I'm going to group my x's together, and I'm going to leave that number that doesn't make it a perfect square on the outside. What I want to do is I want to figure out what value of C makes this a perfect square. But if I add something here, I have to take it away on the outside, otherwise I've changed the entire equation. I'm going to do what I did up here. So 18 divided by 2 gives me 9. 9 squared gives me 81. But if I add 81 there, I need to subtract it right there. So I'm going to end up with x plus 9 squared minus 51. Remember that this is vertex form because this is h and that is k.